Greetings folks, welcome back. In this class we are going to talk about union of set. As I given you an hint in our previous class, union is when we want either of an event to happen. In such case, combination of all preferred outcome for either A or B will be what we'll be considering. For instance, if you work with a betting institution for football, okay, if someone says win or draw for team at home, in case the team at home wins, they win the sport pesa. If that is the betting sorry, that is the common betting institution around, that's why I'm using sports pesa. If I'm saying, if you put, as you place your bet, that is the term they use, as you place your bet, if you say win or lose, so even if the team wins, you get something. If the team draw, you get something. Sorry, if the team draws or win. The mathematical way of we expressing union is, for example, if we have A and B, is by using U. Remember, for intersection we said something like N, right? For union we are going to have this one turning up and down, and of course you will remember by the term union. That will not be very difficult to remember anyway. Okay, let's look at the three ways that we have the set interacting: when they don't touch each other, when they touch each other, and when a set is subset of another set. How do we calculate the union? Point to remember at this place is that when you are getting all preferred outcome for both set that is interacting, you make sure that you avoid double counting. That being said, let's look at the first way we can have when the events is not happening together. Event cannot happen simultaneously, A and B. Okay, in this case, where you cannot have a draw and a win at the same time, so A union B will be equal to set A plus set of B. This is what we'll be having for sorry, I almost used a big term which I don't want to use. If they don't touch each other, we said they can't happen simultaneously, and so we are not in a risk of double counting. We just add them. It is either A or B. That is union of the set. What if the sets are intersecting? For intersecting set, for intersecting sets, for example, drawing a diamond and drawing a queen, okay, they can happen together. We have someone inside here, so the union of, let's say this is A and B, A union B will be equal to A plus B minus A intersection B. Remember when I was introducing, I said we have to avoid double counting. If you count for all queen and all diamond without subtracting this, there will be a double counting for the elements which are here, and that is what we want to avoid. So that is how we find union of sets for intersecting. Then the next one, we are going to have subsetting, where we have red card and we have diamond, red and diamond. So how do we get A, this is A, this is B, A union B will be equal to, remember we avoid double counting and we want to make sure all preferred outcome of both sets are covered. So if we say A, we are covering both of them because B is within A. B is a subset of A, right? So we are not going to have any issue with that. Let's look at an example. For example, we have 8 blonde and 10 brown-eyed people in an office. I don't know if this is applicable in Africa. Do we have brown-eyed people? So we have 8 blonde and 10 brown-eyed people in an office. If only Jason and Eve have both features, that is, have both brown and blonde eyes, how many people represent the union of blonde and brown-eyed? The union of blonde and brown eye is what we are talking about. So we say A union, let's say A represent blonde. So we have how many of them in the set? We have 8 of them. And B, let's say, represent brown. And how many of them are we having? We have 10 of them. So we say A union B is equal to, right, A plus B minus A intersection B. That is what we had. And A intersection B is equal to, we have 2 people, Jason and Eve, is equal to 2. So A union B is equal to 8 plus 10 minus 2. So this is equal to 18 minus 2, which is equal to 16. So A union B, where we know A union B, where we know what both of them are representing, is 16. Thanks for watching. In our next class, we are going to talk about mutually exclusive sets. At least I'll be having some freedom of using some terms. Great, see you then.